Hey, in this video, I'm going to take you to the next level on stoichiometry calculations. So big questions that we're looking at here. What if a stoichiometry problem isn't set up for you at all, right? So far, I've been giving you all the conversion factors and the mole ratios, and all you've had to do is fill in the numbers, multiply the tops, divide the bottoms. How do you know what to write if I don't give you anything in the problem, okay? So I'll teach you how to do that. And then the other thing is, in the lab, we've noticed that sometimes there's a leftover reactant, right? One of the reactants is excess, because there's too much, and the other reactant totally gets used up. That's called the limiting reactant. How do we know which one is going to be used up and which one's going to be excess before we try the reaction, right? Because a smart chemist would want to know that ahead of time. So let's go ahead and dive in. I've got an example word problem right here. We've got the reaction between magnesium and oxygen gas to form magnesium oxide. That's a synthesis reaction. And the question is, if you conduct this reaction with excess oxygen gas, then how much magnesium are you going to need to produce 15 grams of this product? Okay. Now, excess oxygen gas, I've told you in the problem which one is excess. This makes sense, right? If you do this reaction in air, we've got plenty of oxygen in the air, so we definitely have more than enough oxygen gas right here. And that means that the other reactant, the magnesium, that's going to be the limiting reactant, okay? Now, whenever you do a calculation, you always want to look at the limiting reactant if you have a choice, okay? Not the excess. Okay, so how do we do this? Well, I'm going to do one level here, okay? I'm going to do the setup with one extra blank here, okay? So what I'm writing down right now looks very similar to what we've done before, except I just added this one extra blank here in the beginning. And in the past, I've given you that number ahead of time. So today, we'll look at how to do it without having that number filled in already. So go ahead and pause the video to copy all this down. And when you come back, I'll show you how to fill those in. Okay, so you've got this whole thing copied down. And a reminder, a refresher, okay? These two blanks on the sides here, those were called conversion factors. And that was because we are converting from moles to grams, or, forgot to put it in here, from grams to moles on the other side, okay? And when you have a conversion factor, you go to the periodic table to figure out those numbers, okay? So you need to go find the periodic table mass of MgO right here. And then I'm noticing I made some more errors. You can erase the O's on these two. Sorry about that. And then the middle number was the mole ratio. And that comes from the chemical equation, the coefficients, okay? So that leaves this first blank right here. And if you remember way back, this first blank is a number that's always going to be given to you in the problem. So if you reread my word problem up here, you can see there's only one number given to you, and that's this 15 grams of MgO. And you'll look here that it says grams MgO, so it just makes sense that that number is going to be the 15. Okay. Now in my classes, if you can do this problem right here with this one extra blank and the word problem right here, if you can do that and do it perfectly, you can get a B on this test, okay? The A on the test is going to be the same problem with none of this setup at all, and I'm going to do that next. But only one or two problems on the test are going to be like that, so you can still get up to a B if you can do it like this. Okay, so periodic table. Oh, and one more reminder. Sometimes they give you more than one number in the problem. If you get more than one number to start with, choose the one from the limiting reactant. Okay, the limiting reactant determines how far the reaction goes, not the excess. You can ignore the excess. Okay. 15 grams MgO. This number comes from the periodic table. Mg on the periodic table is 24.31 grams and O is 16. So we're looking at 40.31 here. So pop that number in right there. Coefficient numbers right here. This first one for Mg goes right there. And for MgO, we're going to take the number 2 from right there, MgO. So that would be a 2 for both of those. And then Mg on the periodic table is 24.31. I'll go ahead and grab a calculator here so that I can multiply the tops and divide the bottoms, right? So 15 times 2, I'm just going across the tops right now, times 24.31. Now I'm doing the bottoms, divided by 40.31 divided by 2 equals 9.05. And that wasn't so bad, right? 9.05. And then that last unit right there, that's always going to be the final answer units. So 9.05 grams of Mg. That's kind of cool. We just calculated kind of backwards, right? I told you how much product I wanted you to make, and you calculated how much reactant you're going to need to produce that much product, 15 grams of product. Okay. No big deal, right? The only thing we changed here was you had to go find the number 15 in the word problem. What if the word problem is the only thing you get? Okay. So you only get this to start with, 15 grams of MgO. What you need to make note of if you're going to do this same problem with no setup at all, okay? And maybe you need to pause for a quick 2-minute brain break before you hear this, because here it comes. This is important. You need to know where you're starting, and you need to know where you're ending in the problem. And those clues are hidden in the word problem. So the first thing you're going to write down in your setup is the units that you're starting with. The word problem told me to start with grams of MgO, and I even know the numbers, so I can pop that in there. Okay. And the word problem told me I'm looking to find out how many grams of magnesium. That's the end. So again, I'm going to write down the units where I'm going. Okay. That's step 1. Write down the beginning and the end. Okay. Step 2. And I'm going to show each step separately. You don't need to write it down separately on each line if you don't want to, but I want to show you what I add each time. Step 2 is you're going to add 3 sets of parentheses in here. Okay. On the top, well, actually I'm going to talk about this differently. How do you get from grams MgO to grams Mg? Well, you know a couple of things already, right? You know that this is going to be a conversion factor. You know that this is going to be a conversion factor, because it's always that way whenever we do these. And you know that this is going to be a mole ratio. So knowing those things, you can fill a couple things in here. Mole ratio, I know this is going to be moles over moles. Conversion factor, I know it's going to have grams and moles, but which one should go on top and which one should go on bottom? I'm going to go back and take a look at this, the one we already had done, to show you how to remember. Do you remember canceling units? Okay, if you have grams MgO on top and grams MgO on bottom, then we said that those could cancel. And we said that if you had moles MgO on top, moles MgO on bottom, those could cancel. And then we had moles Mg on top and moles Mg on bottom, and those canceled. Do you see there's a pattern here? I'm going to highlight it. Okay, we'll use different colors for each one. The first units, those end up being the bottom units of the next parentheses. The top of this parentheses, moles MgO, that's the units of the bottom of the next parentheses. And it keeps going that way all the way through the problem. The top of this parentheses is the bottom of the next parentheses. So you see the units is how you know what to do next. Okay? So using that pattern, I know since I've got grams MgO on top here, this is going to be grams MgO on the bottom. I know that since this is a conversion factor, that the top is going to be moles MgO. Okay, because conversion factors go from grams to moles. Okay, now I have the top units here, so now I know what to write into the bottom units of the next one. Whatever's the top of the previous one is always the bottom of the next one. Easy peasy. Mole ratio. Moles MgO on the bottom. Moles of what on the top? Well, see the mole ratio, that's where you switch from your beginning chemical to your ending chemical. So that's how I know what to put on the top. I already have, let me get a different highlighter going here. I already have moles MgO on the bottom. So this moles on the top must be the ending Mg moles. So there's lots of little clues here that I'm using to guide myself through the units. Same old trick, whatever's on top, that's got to be on bottom. Moles Mg. And my final unit, I remember, is the same as the ending unit of the problem. So this is going to be grams Mg. Well, now I'm pretty darn close, aren't I? I've got all my units figured out. I just got to fill out my numbers. This is an empty space. 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 Okay. These side moles, these are always ones. That's something you have to memorize. Why is it always a 1? Well, this whole conversion factor, what this is saying is how many grams of MgO are there in 1 mole. That's what a periodic table mass is. It's how many grams there are in 1 mole of anything. Same here, grams Mg in 1 mole of Mg. That's what a periodic table mass is. So that's why that's a 1 all the time. At this point, it's the same as the calculation above. Okay. Was that a lot to memorize? Probably for a lot of you. Okay. If you do enough of these problems, though, the patterns start to sink in, and you can do this with practice. Okay. Again, only 10% of the test is like this. Is it extra memorization? Yes, it is. That's why only 10% of it is worth it. If you want an A, do the work, practice, and you'll get an A. Okay. Go ahead and pause the video, take a brain break. I still have one more topic to crank out in this lesson. I know we're already at 14 minutes in the video, but stoichiometry is a big topic. So take a break, and when you're ready, I'll give you the last piece of this unit. Okay, you've unpaused. And that last piece was big question number 2 up above. How do we know which reactant is limiting? I'm going to do this reaction here. We're going to synthesize water. And this is what the equation looks like. And a word problem might be if you have 15 grams of H2 and 15 grams of O2, which is limiting? And you can't assume that since you have the same amount of hydrogen and oxygen that both of them are limiting. That's not actually how it's going to work out. You see, we need twice as much hydrogen as we need oxygen. Plus, hydrogen is only really light. It's only 2 grams per mole, but oxygen is like 32 grams per mole. So they're not even the same weight. And we don't need the same amount of moles of each. So you got to do some calculating to figure this out. The good news is, it's nothing new. Here's what you do. You start with your 15 grams H2, calculate how much product that would make. Then you do another stoich calculation, starting with your 15 grams O2, and calculate how much product that would make. So you do 2 separate stoich calculations. Okay? (15 grams H2), 3 parentheses. This one is going to end with grams H2O, the product. Okay, then you're going to do a second calculation, starting with the 15 grams of O2, 3 parentheses, and that's going to end with grams H2O as well. Okay, then you just pick the smaller answer, and that's all there is to it. Whichever one of those two is smaller, that's going to tell you which reactant is the limiting reactant. Okay, it's as simple as that. Just like the A-level problems up above, this is not going to be, there's going to be one of these questions on the test. If you can't do this, you can still get a B in the test, okay? But if you want an A, you got to know how to do this. So I'll finish these off real quick. Here's the problem setup. Let's see, moles H2, that's going to be a 2. And this is going to be moles H2O, that's going to be a 2 as well. Okay, so here's one problem set up. Here's the other, grams O2 this time. You hear that hammering? That is a carpenter working in my garage. So I apologize if you can hear that noise and it's distracting. Okay, got my setups. Periodic table for this is going to be 2.02. Periodic table for this is going to be 18.02. Periodic table here, and this is still 18.02. Multiply the tops, divide the bottoms. I'll do this one first. 15 times 2 times 18.02 divided by 2.02 divided by 2 equals, this one gave me 133.81. Next one, 15 times 2 times, wait a second, yep, this is working out, 18.02 divided by 32 equals 16.89. Okay, pick the smaller number. Obviously 16 is smaller than 133. That tells me that oxygen is the limiting reactant in this case. Okay, O2 is limiting. If we use 15 grams of each, the oxygen is going to run out first, and we're going to have excess hydrogen left over. Okay, that's the end of the problem. It's more of the same, basically. So Excellent, excellent attention. This has been a long video. Good job. Happy calculating.